Two function models k and m are constructed to represent the sales of a product at a group of grocery stores. Both k of t and m of t represent the sales of the product in thousands of units after t weeks for t is greater than or equal to 2. If k of t equals this function and m of t equals this function, what is the first time t that sales predicted by the logarithmic model will be 0.1 thousand units more than the sales predicted by the linear model? So we need the logarithmic model, k of t, to be equal to the linear model, m of t, plus 0.1. K and m are already are in units of thousands of units, so we just need it to be k of t to be 0.1 units larger than m of t. So we need to use this equation to solve for time t where this occurs. So let's plug in k of t. So k of t is 14 minus 2.885 ln t, and that equals m of t, negative t plus 14 plus 0.1. So we need to find the intersection between these two graphs. So what we can do is just graph these in Desmos or in our graphing calculator and find the point of intersection. So I've graphed the first function, y1 equals 14 minus 2.885 ln t, which is the left side, and y2 equals negative t plus 14 plus 0.1, which is the other side of the equation. So this logarithmic looking function, the green one, is y1, and the purple one, that's linear, is y2. So to find the value of t where this equation is true, that satisfies both sides of this equation, we can look at the points of intersection between y1 and y2. And we see there are 2 points. One is at a t value of 1.807, and the other is at a t value of 4.32. Now the question asks for the first time t that the sales predicted by the logarithm k of t is 0.1 thousand units more than the linear model. But we also know that these models are only valid for t weeks for t is greater than or equal to 2. So this first point of intersection is at a value of t less than 2. So we can disregard this one. And that means that the first point of intersection is at t value of 4.32. So that means at a t value of 4.32449, the value of k of t is 0.1 larger than m of t. So the correct answer is B.